Hello, this is Mrs. Decker, and this is Objective 3A, defining what acids and bases are and describing the properties of each. So before we get started, I want you to think about these questions. I want you to think about what is an acid, what is a base, and which one do you think is more harmful to us? So take a minute, go ahead and think about those questions. So most students have trouble defining what acids and bases are. Most students think acids are more harmful than bases. So on YouTube, I have posted the link for this PopCan video. I would like you to go and watch it and see how acids and bases both react. All right, so let's start talking about what an acid is. An acid will taste sour and have a low pH. It will turn litmus paper red. It will feel like water, but it can sting if it's very concentrated or cause severe damage if it's very concentrated. It is corrosive to metals, as you've seen in the PopCan video. It is an electrolyte, which means that it will ionize in water, break apart into the positive and negative ions, and because of that, it will conduct electricity. It also contains H plus ions. That is one of the ions, an H plus. You will see this written either as H plus like this, and remember the brackets mean concentration, or sometimes you'll see it written as H3O plus, because really what's happening is the water is picking up that extra hydrogen. So these are the properties of acids. Now some examples of acids are battery acids, any citrus juice, lemon, lime, orange juice, stomach acid, and vinegar. Now let's talk about what a base is. We're going to start with the properties of a base. Bases taste bitter and have a high pH. They will turn litmus paper blue. They feel slippery and smooth. So bleach is a base. If you ever have used bleach to clean something, how it has that kind of slippery, slimy feel. That's what bases feel like. They can be corrosive to metals, again, as you've seen in the PopCan video, and they usually contain hydroxide ions. Not always, but usually. They are also electrolytes, which means they will also conduct electricity. So some examples of bases are soap, dark chocolate, any type of antacid, Tums, Alka-Seltzer, things like that, and sodium hydroxide. So now let's get to the definitions of acids and bases. We really have two definitions for them, and that's because as scientists learned and experimented more, they learned that the first definition did not really apply to all acids and bases, so they needed to come up with the second definition. So for an acid, the first definition is that a substance that ionizes when dissolved in water to produce hydrogen ions, or that H plus you see. Okay? So here we have HCl in the example equation, and it breaks up into H plus and Cl minus. That H plus tells us that it's an acid. And now for bases, the first definition are substances that ionize when dissolved in water to produce hydroxide ions, or OH minuses. So here our example is NaOH that breaks up into Na plus and OH minus. That OH minus, that hydroxide ion, tells us that it's a base. So now, like I said, not all acids and bases fit neatly into these definitions, so that's where our second definition comes into play. The second definition of an acid is it is a proton donator, and the second definition for a base is that it is a proton acceptor. So we say proton because hydrogen has one proton, so that's what we're talking about, hydrogen. So here we have our acid. When it's put in water, it gives up its hydrogen, and we get H3O plus. So that's the way that an acid acts. Here, for the base, we have our base, and when it's put in water, it gains a hydrogen from the water, and we're left with OH minus. So that's where that's how a base will act in water. So now we've talked about the properties and definitions of acids and bases. This is just information that you have to understand and essentially memorize and be able to use. There is some practice in your packet though, so go ahead and work on that and then let me know if you need help.